You need to know dynamic arrays to get better at data structures and algorithms. Hi, my name is Vincent Lamte. I'm a software engineer, and in this video, I'll be walking you guys through what dynamic arrays are, why they're necessary in data structures and algorithms, and how you can implement them yourself. Now, let's go a bit deep and start out by asking, what exactly are arrays? Well, on a low level, arrays are contiguous blocks of allocated memory. So that means that within your memory, that's the RAM, you have slots of spaces, you have slots of memory where you can store some amount of data. And with an array, these slots are sort of stacked one after another in a sequential manner. And that's one of the unique properties of an array. Now, by default, arrays are fixed preemptively. So what that means is that you have to define the slots that you want to hold memory at the time that you're defining your array or you're initializing your array. And you are stuck with this fixed number of slots until perhaps you deallocate or free up the memory. Now, in some modern programming languages like JavaScript and Python, you, on a high level, abstraction level, you typically are provided dynamic arrays by default. And in languages such as C++ and Java, you have vectors and array lists to simulate dynamic arrays. But on a low level, all arrays are fixed by default. Now, this is where dynamic arrays come in. One of the limitations of regular arrays is that, again, you're stuck with this fixed number of slots. So if your data needs to grow, how exactly do you approach that? Regular arrays don't provide an inherent way to resolve that. So dynamic arrays are also arrays, but they are able to automatically grow when there's no space left within your already existing array. So if you have some slots of memory and then it's full, and you want to add more items, dynamic arrays provide a method with which you can expand the amount of slots that you have. So let's look into a bit further as to why dynamic arrays are relevant. As we've already seen, you're no longer stuck to that fixed size of slots. Now your arrays can grow as needed. They're also a good precursor to more complex data structures like stacks, queues, heaps, and hash tables. You'll see a lot of the concepts and methods that we walk through are reused in these data structures. It's also a good introduction to amortized analysis, where you'll get to find out that to measure the true efficiency of a data structure, it's best to measure the average operations for so the average of multiple operations rather than a single operation. We'll go through that in depth later on in this video. And now that we have sort of like a fair understanding of what dynamic arrays are, let's look at how exactly we'd be implementing them. And we're going to be borrowing the concepts within object-oriented programming. So we'll treat dynamic arrays as a class, and then the various features we'd want our dynamic array to have as the properties and methods. So what we'll be, what we'll be creating. We'll start out with our constructor, where we will look at, the different properties within our dynamic array, what we'd like to store. Then we'll also be looking at a get feature. So our array needs to be able to provide for us some sort of value given, let's say, an index. We also like to set values within our array given an index. Then we'd also like to push items into our array. So pushing just being placing items at the very end of our array. We also like to pop, removing items from the very end of our array. We'd like to also resize, which is one of the core things for this dynamic array, where this method will handle how we expand our array to accommodate more items. Then we'll also define a get length method, which will just provide us the number of items we have within our array, and a get capacity method, which will also tell us how many, what's the maximum amount of items that we can hold within our array. All right, so let's look, before we go into amortized analysis, let's look into our writing some code. So here we have our our code base. I'm using VS Code, and this is where we'll be defining sort of like our dynamic array class objects and properties. So I mentioned first thing we need to do is our constructor. So our constructor will take in a capacity, which is what is the initial amount of items that we want our array to take. So capacity is going to be a number. When we pass that into our constructor, we're going to keep that value as a property within this class. Next, we'll also need to define our length. So we need to find, this will sort of track how many items that we already have within our array. Then we'll create a new regular array and give it a size of what we define as the capacity. So say, for example, you'll create an array with a capacity of 4 items, that being it can hold a maximum of 4 items. All of that will be handled within our constructor, where we store the capacity, we store the number of items within our array, and then we're going to create that array. Next, we'll have to define the get method. So given an index, provide for us the value at that index. Now let's run with a base case assumption that the index provided will always be valid, in which case all we need to do is fetch the value at the given index, like so. Right after that, we also need to define our set. So we need to give in an index and a value, set the value at a given index as such. So this is the method that we're handling that. So again, best case, we're assuming that the index provided is always going to be valid or within our capacity. And with that, all we need to do is just set the array at the provided index, having a value as such. Now let's move on to the push method. So this again will be giving a value where we want to insert this at the very end of our array. So we're going to get the current length of the array, and then we are going to place our value at the very end of the list. So if, for example, we have an array with a maximum capacity of 4, and then there are 3 items within the array, the length is going to be 3, and then we're going to push the value. Let's say we want to push a number 24. We're going to push the number 24 at index 3, and that will sort of be how the push works. Now, what if the array is, and right after that as well, we're also going to increase the length. So we've moved from storing 3 items to 4 items. Now, what if the array is 4? So we have an array with a maximum capacity of 4 items, and all slots within our array are 4. Now we'd like to increase the size of that array. Well, if that happens, if the length of the item, that is of course the number of items that we have, is equal to the maximum capacity the array can hold, then we're going to initiate a resize before we run the other operations within push. So let's define what the resize method would look like. Now, with the resize, the first thing that we're going to do is double our capacity. So we're going to, let's say if our capacity was 4, we're going to double that to 8. Next, what we'll do is create a new array with this new capacity, and then fill it up with all the different existing items in our old array. So essentially we're creating a new array and filling it up with the existing items in the old array. So that's what this for loop is here. It's looping through all the items within our old array, and then it's placing them into or copying them into the new array. And after that, we essentially deallocate the old array, and then keep track of this new array as our base array. So that's what the resize will do. Now, right after doing the resize, again, we perform the rest of the actions within push. Now, with regards to pop, again, we are just taking off the last item within our array. But we'll do this in a soft delete way, meaning that we will say that the item is taken off, and we'll return that, but the array doesn't shrink in size or such. So if, of course, the number of items within our array is more than 0, that means we have at least 1 item, then we're going to reduce the number of items that we have to 0. We're going to reduce the number of items that we have by 1, and we're going to return the last item that is within our array, hence the item there. And that would be it for the pop. Lastly, for the last 2 methods, we have the get length. we're essentially just going to return the number of items that we already have within the array. So that's just here, just return this dot length. Again, this is the number of items we have within our array. And then we have get capacity, which is just going to tell us the maximum amount of items we can hold within our array. So we'll just return this dot capacity. And that's what we have for here. Now, with all that said and done, we come to amortized analysis. Now, what exactly is amortized analysis? Why am I bringing this up? Well, for some data structures, you'll find that the best representation of the efficiency of that data structure is by analyzing the average efficiency of multiple operations rather than a single operation, usually referred to as the worst case scenario. So say, for example, with our data structure, a dynamic array, we will see that we do the most costly operation that we have is the resize, but you'll see that we do that intermittently, meaning we don't do that in a sort of a sequential, we do that intermittently. So if our array is 2, we'll double that, and then our array will have capacity 4, but then the next time that we double it is when the array is at capacity 4. So we double that 8, and then the next time we double that is going to be to 16, and then to 32, and so on and so forth. So you'll see that the number of times we perform on resize, even though each operation is essentially an O of n, we essentially average that out to an O of 1. So that's why amortized analysis are useful in such scenarios. The costly operations are intermittent and not frequent, or only occasional. So let's look at the amortized analysis for some of the different methods that we've defined earlier. So for our get, again, it's just a quick random access. It's going to be an O of 1. For the set as well, we just set it at the given index. That's also going to be an O of 1. The push with a resize is going to be an O of n, but again, we only do this occasionally or frequently, and we'll see that it averages out to an O of 1 complexity. For the pop as well, we're just taking out the last item, that is going to be an O of 1. For resize, that's also resize is going to be an O of n. We'll clear that there. And then for get length and get capacity, they're also going to be an O of 1. So that really is it for dynamic arrays. I really hope that this helped clear some concepts for you guys. Again, my name is Winston Lamte. Do subscribe and share if you find this helpful, and I'll catch you guys in the next one.